Hello friends, welcome to MathAlcoholic once again. So in this video I'll be starting from question number 8 onwards of miscellaneous exercise that belongs to inverse trigonometric functions class 12 NCERT Mathematics. So basically in these 3 questions we need to prove these identities. Okay, so starting from question number 8, we have tan inverse 1 by 5 plus tan inverse 1 by 7 plus tan inverse 1 by 3 plus tan inverse 1 by 8. Alright, and this is the LHS. Okay, we need to prove that this is equal to pi by 4. So by seeing it's a pretty direct question, friends, we can add any of the two by the formula of tan inverse x plus tan inverse y, which will be forming a pair once again. So for here, let us take these two pairs, tan inverse 1 by 5 plus tan inverse 1 by 7 and tan inverse 1 by 3 plus tan inverse 1 by 8. You can take any other, just that involves a bit of calculation. So let's take it. Combining this 1 by 5 and 1 by 7 is going to give me 1 by 5 plus 1 by 7 by 1 minus 1 by 5 into 1 by 7. Alright, combining 1 by 3 and 1 by 8 will be giving me 1 by 3 plus 1 by 8 by 1 minus 1 by 3 into 1 by 8. Alright, now what is left is just calculation and nothing else. So this is going to be 7 plus 5, that is equal to 12 by 35 into 1 minus 1 by 35, and here lies tan inverse of 11 by 24 into 1 minus 1 by 24. Okay, so this gives you tan inverse of 12 by 34 plus tan inverse of 11 by 24 minus 1, that is 23. Now you can reduce 12 by 34 into 6 by 17. Okay, so this is going to give you tan inverse 6 by 17 plus tan inverse 11 by 23. Now since this 4 we can reduce it into 2, and similarly these two terms we can reduce it into one term once again by applying the same formula. So we'll be having 6 by 17 plus 11 by 23, tan inverse of x plus y by 1 minus x y. Alright, so by a bit calculation this is going to give you tan inverse of 23 into 6 is 138 plus 17 into 11 gives you 187 by, this is 17 into 23 which is 391 into 1 minus 66 by 391. Okay, so this is going to give you tan inverse of 325 by 391 minus 66, that is equal to tan inverse of 325 by 325, that is equal to tan inverse of 1, and that is equal to pi by 4, which is equal to RHS. Okay, hence LHS is equal to RHS. Verified or proved, anything you may say. So we completed the first question of this video. Coming to question number 9, we need to prove that tan inverse of root of x is equal to half of cos inverse of 1 minus x by 1 plus x. So we'll be solving it here. Now, if you can catch it, it's pretty easy. So starting our question number 9, we'll be starting with the RHS because this is a bit complicated. We'll be reducing it into LHS. Okay, it is the given condition. The LHS is tan inverse of root of x. So we can intuitively take this to be theta. Okay, so that we are finding x from this. This is what we'll be doing. There are many approaches to it once again, but this is the shortest one. So let tan inverse of root x, which is the RHS, I am just assuming this is equal to theta. So therefore tan theta is equal to x, and it gives me tan theta is equal to root x, and hence x is equal to tan squared theta. Okay, tan theta is equal to root x and x is equal to tan squared theta. So therefore we have half of cos inverse of 1 minus x by 1 plus x as half of cos inverse 1 minus tan squared theta by 1 plus tan squared theta. Now 1 plus tan squared theta will be giving you sec squared theta. So this is 1 minus tan squared theta by sec squared theta. If you take sec squared theta into the numerator, you have to transform sec square theta into cos square theta, and cos square theta into 1 minus tan square theta will be giving you half of cos inverse of cos square theta minus sin square theta. And if you remember, this is the formula of cos 2 theta, so this is going to be equal to cos inverse of cos 2 theta. I'm sorry, so this is cos 2 theta, okay, and cos inverse of cos 2 theta will be giving you 2 theta, because this x is from 0 to 1, so you are free of any kind of problems. You can directly write cos inverse of cos 2 theta as 2 theta. So half of 2 theta is going to be theta, and you had assumed theta to be tan inverse of root over x. Okay, therefore we can say half of cos inverse 1 minus tan square theta by 1 plus tan square theta to be tan inverse root x, hence proved. Okay, so I think this was an easy one, you have no doubt in it. Now coming to the last question of today's video. Here we are said to prove that cot inverse of this expression is equal to x by 2, where x belongs to 0 to pi by 4. So we are given the expression as cot inverse of root over 1 plus sin x plus root over of 1 minus sin x by root over of 1 plus sin x minus root over of 1 minus sin x. Okay, where x belongs to 0 to pi by 4. Now if we are seeing this kind of shitty thing, the first thing we'll be doing is rationalizing it. The first thing that will be coming to our mind is to rationalize it. That is what basically we'll be doing right now. So now root over 1 plus sin x plus root over 1 minus sin x by root over 1 plus sin x minus root over 1 minus sin x. This is going to give you, if you just rationalize it and if you remove these root expressions from the denominator completely, you need to multiply this by a positive quantity. So basically we would be just rationalizing it in a very simple way, square by, now here if this is a, this is b, so a minus b into a plus b, that is what we need. So we multiplied a plus b in both numerators and denominators. So since numerator is the same as a plus b, it got squared, and this we are left with root over 1 plus sin x whole square, since a minus b into a plus b is equal to a square minus of b square. Okay, so this is going to give me, just expand this square, so root over 1 plus sin x whole squared is 1 plus sin x plus root over 1 minus sin x whole squared is 1 minus sin x plus 2 into ab, means that means 2 into root 1 minus sin x into 1 plus sin x. Okay, and in the denominator you simply have 1 plus sin x minus 1 plus sin x. Minus of 1 minus sin x will give you minus of 1 plus sin x. Okay, just we need to solve it. Here 1 and minus 1 gets cancelled, here sin x and sin x gets cancelled, so the numerator is 2 plus 2 of this. So this is, if I take 2 common, so this is 1 plus sin x into 1 minus sin x will be giving you 1 minus sin square x. Okay, so this is going to be root over 1 minus sin square x by sin x plus sin x is 2 sin of x. So 2 gets cancelled. Root over 1 minus sin square x is root over cos square x, and root over cos square x is just cos x. Okay, since there are no complications as x belongs to 0 to pi by 4, so this is going to give you 1 plus cos x by sin x. Now if you take cot inverse, so you need to transform it into something in cot. So this can be easily done by this 1 plus cos x. If you write it with the formula of 1 plus cos 2 theta, so it will be going to be 2 cos square x by 2. Okay, and the denominator sin x, you can write it as 2 sin x by 2 cos x by 2. These are the prevalent trigonometric formulas. Okay, now 2 and 2 gets cancelled, cos x by 2, and 1 power of it gets cancelled from the numerator, so we are left with cot of x by 2. So therefore cot inverse of root over 1 plus sin x plus root over 1 minus sin x by root over of 1 plus sin x minus root over of 1 minus sin x, that is equal to cot inverse of cot of x by 2, and since x belongs to 0 to pi by 4, this will be giving me x by 2, which is equal to RHS. Okay, therefore LHS is equal to RHS, proved. Okay, so I hope you have no problem in solving this. If you have any kind of problems, please feel free to use the comment section. So I'll be coming up with a new video where I'll be discussing the next questions. Thank you very much for watching this video.